Hey guys, Dr. Brown here, and tonight we're looking at the integral of 5 sine theta cosine theta divided by sine squared theta plus 3 sine theta minus 4 integrated with respect to theta. Now some of these are not difficult problems, but each semester there's a new crop of students out there that may be looking at different tools to try to help them solve problems. So the tools that we talk about on this channel, we use the acronym UTI PPLCQ, which is U sub, trig sub, integration by parts, partial fractions, power reduction, long division, completing the square, and something that I call method of quadratics. So when you look at a problem, to try to help organize yourself, which of the tools do you need to use to be able to do something here? Well, there's also when in doubt factor. Okay, there's that. But you know, when you look at sine and cosine, they're big buddies because the derivative of sine is cosine. So I know in the numerator, I have 5 times something and its derivative. So the derivative of sine theta is cosine theta d theta. So when I learned integration, we would say, well, that's u and this is du. Now we use a different method to try to help make it more obvious, but okay, let's move to the denominator. If this becomes u, well, this is u squared plus 3u minus 4. Hey. Now it becomes very simple. So let's use u sub in the beginning. So let's let u equal sine theta. So du equals cosine theta d theta. And this is what I like. The way we learned it, like I said, we would put a circle around this. Oh, that's du. But why not take this and solve it for d theta so that I have something I just plug in for that? So let's divide both sides by cosine theta. I don't have to get weird on this thing here. I can just say d theta equals that. Plug it in. So let's pull the 5 to the outside. So now we have u. I still have that cosine theta over u squared plus 3u minus 4. And d theta is what? du over cosine theta. Wow, they just cancel. Now, I can look at this, when in doubt factor, as I said. So I had 5 times the integral of u over u plus 4 u minus 1. du. So u squared plus 4u minus a u gives me that 3u minus 4. Okay? Now what tool should we use? I have 2 fractions, or something that I could use partial fractions on. So I could say, well, I'm going to let this be, in their linear terms, is the integral of a over u plus 4 plus b over u minus 1 du. So all of this equals that. I have this 5u. So if I were to multiply both sides by u plus 4, u minus 1, if I do that here, I have, well, if I do it on both sides, it all cancels here. I'm left only with 5u. That equals the u plus 4 would cancel, and I'm left with a times u minus 1 plus b u plus 4. Okay? Now then, we're just actually choosing numbers here for u in an attempt to wipe out a piece of this. So in this case, if I let u equal 1, so u equals 1, 5 times 1 is 5. 1 minus 1 is 0, so this all wipes out, plus 1 plus 4 is 5. So I have 5b equals 5, so b equals 1. Okay? Now then, let's let u equal minus 4, and we'll wipe out the other one. So minus 4 times 5 is minus 20. Minus 4 minus 1 is a minus 5. So I have minus 5a plus minus 4, this is 0. So negative 20 divided by negative 5 gives me a positive 4, and that equals a. All right, so a equals 4. Plug that in right there. B equals 1. This is a cool thing about partial fractions. Okay, it allows me to take and break this fraction into partial fractions, thus the name, and it becomes much simpler. So I have now the integral of 4, 1 over u plus 4 du plus the integral of 1 over u minus 1 du. This is a natural log, 4 times natural log of u plus 4, because the derivative of u plus 4 is du, because the derivative of a constant is 0. So that's the integral of the derivative of the function over the function. Same situation here. What's the derivative of u minus 1? It's du minus 0, so du over u. So that integral. So here I have the 4 natural log of u plus 4 plus natural log of u minus 1. Well, what is u? U is sine theta. So 4 natural log sine theta plus 4 plus the natural log of sine theta minus 1 plus c. And that, my friend, is the results of this integral. So the tools we used, u sub and partial fractions. So not a complicated problem, but again, as I stated earlier, the purpose of these is to begin letting you decide what tools to use and then apply those and then get the results. I would encourage you to take the derivative of that and see if you get this, okay? Why are we doing this? Together, we're trying to build a better tomorrow through math. Keep studying, and we'll talk to you next time. Thanks.